In this lesson, we're going to be looking at systems. Our objectives are to understand what a system of equations is, to understand how to find a solution to a system, and to understand how to check if a solution is correct. Vocabulary is system of equations. Set of two or more equations with common variables, meaning they're going to have the same variables, such as they'll both have x, they'll both have y, or combinations of the two. The most basic thing that we need to look at is what they look like. All systems should have these braces in front, and then these braces are what kind of group our equations together. We have two linear equations here, both in intercept form. The form really doesn't matter as long as they're within the braces. Here we have two linear equations in a different form. Here I've shown you what it looks like if you have something that is of that has three equations. Notice that the z is not in the second or the third one. The y is not in the third one. That would just mean that there is a 0 in front of the y or a 0 in front of the z, but this still works. We could also use things other than linear equations. These are all linear though. So the next thing that we want to look at is how would we find a solution to a system? Well, in a system, if you want to find a solution, the most basic way, the way that is usually the simplest for us to understand, is graph the equations. If we graph the equations, we will typically see some overlap or a crossing of the equations, and that would be our solution or solutions if it crosses in more than one spot. So we'll start with this one. This is pretty simple, so we'll just make a table for it. Okay, so we are going to put 0 in for x. So 2 times 0 minus 1 is negative 1. We're going to put 1 in for x. 2 times 1 is 2 minus 1 is 1. And put 2 in for x. 2 times 2 is 4, minus 1 is 3. Looks like a pattern of adding 2, so I'm going to go with that. So we then graph this, 0, negative 1, 1, 1 here, 2, 3, and 3, 5. Okay? And then we would take a straight edge, and it looks like a little off, and draw our line. Now, one of the things that we'd like to do is usually extend this line both ways because we don't know exactly where it's going to cross. So now we'll do our second line. This one isn't solved for y, so we're going to want to move the x. So I'm going to minus x from both sides. We're going to get this as being y equals 5 minus x. Okay, so 5 minus 0 is 5. 5 minus 1 is 4. Minus 2 is 3. Minus 3 is 2. So we've got 0, 5, 1, 4, 2, 3, and 3, 2. So we have this here. Draw our line. And as you can see, it crosses right there. If you look in the table, sometimes this happens with the table, where you see it in the table that these are the shared point. That would be our solution. So our solution is 2, 3. With a system, one of the other things that we need to do is just be able to check whether someone else did it correct. So what I'm now going to look at is this problem like someone else did it, and me just checking if this solution of 2, 3 is a good solution. So what we have to do is we have to check this answer for both problems. If it checks out for both problems, it would be an acceptable solution. If even one of the problems doesn't work, then it's not a solution. So we'll start here with this one, and what we do is we'll take we've got an x and a y, we're going to put those into the problem and just see if both sides are equal. So 3 goes in for y, so we're going to get 3 equals 2, we want to put 2 in for x, so times 2, and then minus 1. There's no math to do on the left, but on the right we have 2 times 2, which is 4. And 4 minus 1 is 3. So this one is okay. That works. So we got one of them that works, we need to check the other one. So we're going to put 2 in for x. We're going to put 3 in for y. And we're going to check if this works out. So here we've got 2 plus 3 is 5, equals 5. That one also checks out. Therefore the solution works. Okay. Make sure that you're checking other people's solutions, as this is important because there's always times where we could graph or estimate things incorrectly, so we want to always check if our solution works or not. If there's any part of this lesson that you didn't understand or you need to see again, please pause, rewind, and rewatch, and bring any questions to class. Thank you.